Hey guys, guess what? We're at the final part of our geometry series on slopes, lines, and distance. And we're going to discuss the distance formula this time. So, suppose we have 2 points and we want to know the distance between those 2 points in a coordinate system. Okay? So, we have point 1 where we with x1, y1, and we have point 2 with x2, y2. So how do we use those coordinates in order to find the distance? Well, okay, of course, you have the distance formula. Okay, But where does it come from? Okay, why are we doing what we do? Okay, I like to know where stuff comes from. So let's discuss that. Now, let's call the distance between these 2 points, let's call that D. Okay? And stick with me because this is headed someplace, okay? Now, when we talk about point 1 and its location within a coordinate plane, this means that this here on the x-axis would be x1, and don't laugh at my non-straight lines, this would be y1, okay? So x1, y1, okay? That's where they would be located on the x and y axes, okay? So now the same is for point 2. That means that this here would be our x2, and oh wow, say I need a ruler, okay? Let's see, don't even try it, right? Okay, I don't even think I'm gonna make it with a ruler, really. Okay, let's see. Okay, stop laughing, okay, you know what? I'm just gonna have y'all laugh at me, okay? Cause this is not easy, especially coming across this way, okay? Can she do it? Can she do it? Okay, and I'm going to have to try to join it here. Yay! Okay. That was a task, and it turns out that this is y2, that's x2. There we go. Okay, all right. We're cooking with oil now. Okay, so we did that because we want to find this distance here. Why do I want to find this distance right here? Okay, and we also want to find this distance right here as well. Okay, that should look a little familiar actually. Okay, notice how this is on an incline right here, right? So it's sort of like when you're dealing with like slope, you have your rise over run. Okay, well, instead of playing around with slope, because we're going to be, if we did that, we would be going in circles. Let's look at what we call the Pythagorean theorem, okay, because that is what the distance formula is derived from. It's derived from the Pythagorean, if I can say it, the Pythagorean theorem, okay, and he derived it from the African Egyptians, okay, but, okay, that's a long story, but anyway, all right, so the distance formula is derived from the Pythagorean theorem, and long story short, the Pythagorean theorem is where if you have a right triangle, we're going to pretend like that's a right triangle. That is so ugly, okay? Stop laughing. I know y'all laughing, okay? I can hear you through the video. Okay. That is a right angle, okay. So if the line in a triangle opposite of a right angle, 90-degree angle, is what we call the hypotenuse. And we typically name it C, okay? You would think it would be H, but it's C. And the other two legs of the triangle, one would be A, the other would be B. And now I'm kind of assuming that you all are familiar with this formula here, but basically it is C squared is equal to A squared plus B squared. Actually, I kind of jumped ahead of myself. It's actually a squared plus b squared equals c squared. And we're going to rearrange the equation to look like this because in our case, what's opposite, the distance here is opposite of this 90-degree angle right here. And so in our case, that's going to be what we call c. So plugging into this formula right here, if I gave myself any room here, that would be d. Okay, so it would be d squared is equal to this distance, and we'll go ahead and call it b, okay, and we'll call this one a. So it's going to be a squared plus b squared, okay, and we're going to plug in for a and b. Okay, in our case here, a is going to be this distance here, right, and b is going to be this distance here. So that means that a would be the difference in the y-coordinates, and b would be the difference in the x-coordinates. Technically, it's the absolute distance, the absolute value. But anyway, essentially what we're going to do is we're going to plug into this equation right here the values of a and b. So I need to erase this here to give myself a little room. So a is going to be, in our case, I would like to try to follow my notes. I like to put it in terms of y2 minus y1, for instance, and x2 minus x1. So it's going to be squared plus x2 minus x1 squared. Okay, so all I did was plug in, right? Plug in for a and b here. And then we have our d, our distance. Just bring that down. Distance squared is equal to this value squared plus this value squared. Okay? So now if we want to find just d, but we have d squared, then we have to take the square root of both sides. Okay? And when you do that, technically you get, you know, two values, and it's a negative, all that good stuff and everything. And actually, I'll talk about that in my book. So, again, go to the website, www.declaremath.com, and check out my book. It's free, okay? And actually, I kind of go over some of that stuff as far as how to handle roots and powers, and I give some examples on how to handle taking the square root of equations and blah, 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 blah. Okay, so that's like advanced algebra stuff. So, and it's in there. So go check it out. All right, so